Hello everyone, in this tutorial we are going to discuss how to draw the isometric view of scale hole of 20 mm drilled centrally into hexagonal prism of base edge 30 mm and height 60 mm. So you can see that this is my hexagonal prism and this is a scale hole which is passing centrally through the hexagonal prism. If we have to draw the isometric views of the solids, so we have to draw the orthographic top view of the solids. Now let's see how to draw the orthographic top view of the prism. Now you can see this. So this is my top view. Let's see how to draw this one. So you know that I'm just making the hexagonal prism top view. Okay, so this is my top view of this prism. Now I'll give the nomenclature of this one, and this is 30 mm, as we know that the base edge is 30 mm. So this is my nomenclature. Now I have to draw this scale hole top view as well on this top view of the hexagonal prism. So to draw that, we know that we have to show the center of this one. So to find out the center, first we have to draw this line. This is a midpoint and this is also midpoint. Let's just join the midpoints, and again I make this one. Okay, so wherever these two lines intersect, that is the midpoint of this hexagonal prism. So from here I'm going to make this scale hole. The dimensions of this one is 20 mm. Okay, so this is my scale hole which is passing through centrally through this hexagonal prism. To solve these types of questions, we have to use the method. That method is known as box method. And what is this box method? We have to put my hexagonal prism in between the box, and you have to draw the box first in isometric view, then we have to draw the our solids in that. Okay, so you can see here, this is my box and in between we have this my prism. Now let's see how to proceed further. Now if you see here, we have to draw the top view of my box as well. So here we have to make that as well. So you can see here, this is my line, and just I'll complete my box top view over here, and you know that this is PQRS, so this is point PQRS. Okay, so let's see how to start further. And this is, I'll take the dimensions of PQ and PS. So this is my dimension, this is PQ and this is PS. So I'll take these dimensions as well. So we have to draw this PQRS, which is in the form of rectangle over here. I have to make this rectangle initially in isometric view. So let's see, I'll take a point P over here. This point P comes over here and I'll start making over here. So this is PQ and PS line. So according to the dimensions from here, which is PQ is 52 and PS is 60 mm. So I'll take these dimensions at an angle of 30 degree, because I know that in isometric projections you have to take lines at an angle of 30 degree. Okay, so in the same way I'll make this line SR, which is parallel to PQ, and the dimensions are same, and this RQ is equal to SP and parallel to it. So I'll complete my rectangle, which is PQRS, at an isometric view of this. So on this I'm going to take the dimensions now, and now you see that I have to take this P1. So P1 is 15 mm. Okay, so I'll take a compass and come over here and put the steel part of the compass over here on the P and mark an arc which is 15 mm, because my P1 is 15 mm. Okay, in the same way S2, so you can see that S2 is also 15 mm. So I'll put my steel part over here and make an arc which is S2. In the same way I'll complete everything over here. Again I'll take the compass and make an arc which is 26 mm. So this is 6 point. In the same way I'll complete everything. So on SR we know that this is 3, so I'll take 3 over here, and then this one R4, and that is Q5. So now I'm going to join these points. So with the help of pencil and scale I'll join it. So you can see that Now I'm going to take the height of this box. So from P to W, I know that whatever the height of the solid is, it is completely same. So PW is 60 mm. So I'll take PW, that's 60 mm. Okay, and again from Q, that is QX, again 60 mm. So I'll complete my box as it is. Okay, you can see this. I'll complete my box. So this way I'm going to complete my box. After completion of this box, now I'm going to take the 60 mm from every point, like 1 2 3 4 5 6. Okay, you can see that this is 1 to A. Okay, I'll take this nomenclature A. Okay, then 6 to F. Okay, and in the same way 5 to E. Similarly, I'll take 60 mm from all the points like this. Okay, so this is the hidden lines. As you know that this is the back of your hexagonal prism, so this must be hidden edges. Okay, so in the same way I'll take this one and I'll just join these points with the help of pencil and my scale. So this is my hexagonal prism. In isometric projection topic, there is no need to show the hidden lines. Okay, so I'll delete these hidden lines. This is also hidden part. So now you see that this is my only hexagonal prism. Okay, now I'm going to make a hole over here, which is square hole and passing centrally through here. So again, it is a center. You have to find out the center here. So this is a center line passing through the midpoints of this ZW, and this is YX, and also this is a WX midpoint, and this is ZY midpoint. So I'll just join these lines, and wherever these lines intersect, that is the midpoint of that. Okay, so from here midpoint, I'm going to make a square hole, which is KLMN. How to make this square? Just take a dimension of 10 mm towards this direction and make a line which is KL. Now you see that KL dimension is 20 mm and it is passing through the center line. So 10 mm toward this side and 10 mm toward this side, and also this dimension is also 10 mm because it is from the center point, and this is 10 mm. Why it is 10 mm? Because complete edge is 20 mm, because we know that square hole is of 20 mm. Okay, in this way I'm going to complete my square. So you can see this is 20 mm, this is LM, and again 20 mm toward this side, and this is again MN, and I'll just complete this one. So this is my square hole on the top of my hexagonal prism, and it is centrally drilled through the hexagonal prism. So you can see that it is 60 mm downside, and it must be hidden line, and again from L and M and N. So these are again perpendicular lines towards downside from KLMN. This is a perpendicular line, and the height of these lines is 60 mm because the height of the solid is 60 mm, and you have to join in the downside like this. And you know that when you have the isometric projection, there is no need to show the hidden part of that. So you may remove these hidden lines if you don't want to show this. So this is my solution of this question. I hope you understand this question, and please subscribe my channel and recommend my channel to your friends. Thank you everyone.